Welcome to Mathematics. This is the Edexcel International Advanced Level M1 paper from January 2024 exam sessions. So starting with question 1, we're given that a small smooth ring, this ring C, it's threaded. So if something is threaded, the tension on both sides of the string will be equal. So we have that information. And that a horizontal this 2 Newton in force, we are given that it rests in equilibrium with the spring taut vertically below V. We are given that the mass of the ring is m kg. We are also given that the tension is T newtons, and we have this information. So tan theta is 3/4. So tan theta 3 is the opposite. So this, if this is 3, this is 4. So this will be root over 3 square plus 4 square, which is 5. So this is a 3, 4, 5 triangle. So we also know the value of sine theta, which should be the opposite 3 by the hypotenuse 5, and cos theta will be 4/5. It's better to find these values out if we have a question like this featuring angles. Okay. Now in question A, we have to find the value of t. If we resolve it vertically, we know that this is mg. So this is also a variable, so that won't work. However, in the horizontal plane, the horizontal component of t would be t cos theta, because this angle is theta due to it being an alternating angle. So there is already a t over here, and this t will have a component vertically as well, so this will be t sine theta. So we have resolved this. Now if we resolve it horizontally, we'll get t cos theta equals to 2. So t into 4/5 equals to 2. So t is 2.5 newtons. So this is the answer to part A. Now for part B, we have to find the mass m. We know that mg equals to t plus t sine theta. Mg equals to t plus t sine theta. So we know the value of t, we can just plug it in. So 2.5 plus 2.5 times 3/5. We'll get a value of m, which would 0.408. So that's it for question 1. Now in question 2, it's a question about the momentum. We are given the following details. The mass of A and B. We are given that before the collision, A had a speed of 3 meter and B x, and they were moving in opposite directions. So this will be 3 and this is x. After the collision, the speed of A is 1 meter per second. Its direction of motion is unchanged. So A has a speed to the right of 1 meter per second. We are given that B has a speed of 5 meter per second, 1.5 meter per second. We aren't given any details of its direction. However, we can figure it out directly. If B was moving 1.5 meter per second in this direction, it wouldn't be possible because it would keep colliding with A. So it would be this way. Sorry for what was written before. So in this question, we'll use the conservation law of momentum. So M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. So in this case M1 was 5 into 3 minus, because x is in the opposite direction, we'll have minus x square equals to 5 into 1 plus we have m2 v2, so 1.5x. Now we'll have 15 minus x square equals to 5 plus 1.5x. If we move it if we move this to the right, we'll get x square minus 15 plus 5 plus 1.5x equals to 0. So we'll get a quadratic x square plus 1.5x minus 10 equals to 0. Now if we solve this, then we'll get the value of x. So we'll get the values of x equals to 2.5 and x equals to minus 4. We cannot take the negative value since x has to be positive. If x was negative, it would mean that it's moving away at a speed of 4 meters per second. So they wouldn't even collide if that was the case. So we'll not take this. So x equals to 2.5. Now we have to find the magnitude of the impulse. We can do it with either one of them, either particle A or particle B. I'll prefer particle A because we are given all the information from beforehand. In part B, if we made a mistake calculating x, we might lose further marks if we don't have marks for error carried forward. So the impulse would be its mass, its final velocity is 1 meter per second and its initial velocity was 3. So we'll get 10 Newton seconds negative, and the magnitude will be 10 Newton seconds. That's it for question 2. In question 3, we are given that a van is traveling with constant acceleration. We are given that it passes point A with speed u, and 20 seconds later it passes point B with a speed of 28 meters per second. We are given the distance AB. We have to show u. So the information we know is u. We have to find u. So u is the question, and the values we know are the values of t, v and s. So we don't know the acceleration over here, so we'll use this formula, s equals to u plus v by 2 times t. This is the equation we'll need because we don't have the acceleration yet. So 400 is the displacement, initial velocity is u, the final velocity is 28, and the time is 20. We can divide both sides with 20, get rid of this. So we'll have 20 on this side, and on this side we'll have u by 2 plus 14. So u by 2 will be 6, 20 minus 14. So u will be 12 meters per second. And that's it. This was the show questions. Now we have to find the time taken for the van to travel from A to the midpoint of AB. So AB is 400 meters. So the midpoint of AB will, if we think of it as a line, this is A and this is B. This is 400 meters. Now half the distance will be 200 meters, the midpoint. If we name this distance C, AC will be 200. We can take various approaches to do this. As the acceleration in this time period is constant, we can find the acceleration. We know the u, we know the distance. We don't know the time is the question. We don't know the velocity at c. We don't know the velocity at c. The final velocity is the velocity at b, which is given 28, but we don't know this. So if we calculate the acceleration, we'll have the initial speed, the acceleration, and the distance. So we can find out time by using s equals to ut plus half at square. So let's find the acceleration using the values given in the first question. We are given that u is 12, velocity at b is 28, and time to reach b is 20 seconds. And we need to find acceleration. So we can use v equals to u plus at. So 28 equals to 12 plus a into 20. So acceleration will be 4 by 5 meter per second square. So now we can find this t, the time to reach c. So the initial velocity is 12 again. We don't know the velocity at c. We know the acceleration to be 4 by 5. The displacement is 200. And we have to find the time taken to reach c. So we can use s equals to ut plus half at square again, because we don't have v. So s equals to ut plus half at square. You'll get 200 equals to 12t plus half into 4 by 5 t square. So this is 200 equals to 12 plus 2 by 5 t square. So we can solve this quadratic. We'll get the values of t to be minus 15 plus minus 5 root 29. We cannot take minus 15 minus 5 root 29, as this will give a negative value of t, which is not possible. So the time is minus 15 plus 5 root of 29, which is approximately 11.9 seconds. Now we have to find now we are given the mass of the van, and that it experiences a constant resistive force of magnitude 260 Newton. So we have to find the magnitude of the driving force exerted. So if we look at the unbalanced forces over here, we have the driving force in the front, F, and we have a resistive force which is 260 newtons, a resistive force of 260 newtons over here. This has a mass of 12,000 kg. Yeah, 1200, not 12,000. And it has an acceleration of 4 by 5 meter per second square, which we have found out in the last question. So the if we'll use F equals to ma over here, the unbalanced force will be F minus 260 equals to 1200 times 4 by 5. So force will be 1200 into 4 by 5. The force will be 1200 to 4 by 5 plus 260. So we'll get 1220. I don't think that, okay, that's right. So the driving force will be 1220 newtons. Now on to question 4. We are given a force diagram, and from that we have to find x. We are given the resultant magnitude of P and Q, the magnitude of Q, and we have to find the magnitude of P. So we'll have to find the resultant vector of this. So if we because the vector needs to be a head to tail diagram, it would be like this. So this is P, this is X, and the resultant vector, this vector has a magnitude of root over 129. This angle will be 30 degrees, and we don't know the rest of the angles. So we can use the cosine rule over here to find x. So cos 30 will be the adjacent side squared, so x squared plus 5 root 3 whole square minus root over 129, the opposite squared, divided by 2 times the adjacent side x and 5 root 3. Cos 30 is root 3 by 2, so we'll have root 3 by 2 equals to x square plus 75 minus 129, and you have 5x root 10x root 3. So if we cross multiply, this will multiply with this will multiply with this, so we'll have 10 root 3 minus 10 root 3, oh no, we'll have 10 into x, 10x into root 3 square, so that will be 3, so 10 into 3x, and on this side we'll have 2x square. 75 minus 129 is minus 54, and you times 2 it, you'll get minus 108. So this will be 2x square minus 30x minus 108 equals to 0. If we solve this, we'll get the values of x 18 or minus 3. X cannot be negative here, so x is 18. Now we have to find the angle between Q and the resultant. The resultant is this red vector over here, and Q is this vector. So the angle they are wanting from us is this angle over here. It's not 150. So we can use the sine rule over here. So if we consider this theta, sine theta by its opposite angle, which is x, we found out that it's 18, equals to sine 30 by, we know this angle, sine 30, and its opposite side is root 129, so it will be sine 30 by root over 129. Now if we solve this, sine 30 is half, so 18 into half will be 9. So if we take sine theta as the subject, we'll get 18 times half by root 129. So theta will be, the basic acute angle will be 52.41 degrees. We have to give our answer to, this is not the answer yet. This is the basic acute angle, but if we see this diagram, theta must be up. So theta would be 180 minus 52.41. So we'll get 127.5 degrees, and to the nearest degree it would be 128 degrees. That's the answer. Now to question 5. We have a beam of mass 30 kg, length 3 meters. So this is a question about moments. We are given this information about the distances, and then we are added that a person of mass 55 kg stands on the beam between C and D, so between these points. The person is modeled as a particle, and we are given that Cp is x meters, with x between 0 and 2.2. So this is where the person is. Now we are given, we have to show that the reaction at C is 686 minus 245x. The beam is a uniform rod, so its center of gravity will be from the middle. So, well, we are given that x is between 0 and 2.2, so 0.4 plus 0.22 is 0.62. So this is less than 1.5, so the center of gravity of the beam will be to the right of it. So this is 30 g, this is 55 g, this is the reaction at C, this is the reaction at D. In question C, we still don't know the reaction at D, so we can take the moments about D. So the reaction at D will be, we'll have a distance of 0 from the pivot, so it will go away. So considering D as the pivot, this is our pivot. We have these two forces providing anti-clockwise moment, and we have reaction at C producing the clockwise moment, and they'll be balanced. So we'll get, since this distance is 0.4, this distance will be 1.5 minus 0.4, because this distance is 1.5 meters, or half of the uniform beam. So this is 1.1. Also, from D to C, the distance is 1.3 minus 0.4 minus 0.4, because there is a 0.4 over here and 0.4 over here, 0.4 over here, a 0.4 over here, and the whole rod is 3 meters long. So 3 minus 0.4 minus 0.4, which will be 2.2 in the middle. So this is 2.2. If that's 2.2, this will be 2.2 minus x. So if we calculate, we have anti-clockwise moment equals to clockwise moment. So 30g into 1.1 plus 55g, 2.2 minus x, equals to 2.2 reaction at C, and we need the reaction of C as the subject, so we'll get calculate this, will get 30G into 1.1 will be 33G. Then we'll have 121G minus 55XG or minus 55G of GX, and this will be divided by 2.2. Since this expression doesn't have G in it, we'll break it down. So reaction C equals to so we have 33 into 9.8 plus 121 into 9.8, so we can just add them together into 9.8. So 1509.2 minus 55 into 9.8, 539x divided by 2.2. So we'll divide both values with 2.2. So this is minus 245x, and 1509.2 divided by 2.2 will be 686. So the reaction of C is 686 minus 245x, which matches with what they wanted. Now in part B, we are told that the magnitude of the reaction at C is 4 times the magnitude of the reaction at D. So we have to find the value of X over here. So reaction of C is 4 times the reaction of D. And we also know that the reaction of C plus the reaction at D, which is the upward force, this is the upward force, and the downward forces are 55G plus 30G. So upward and downward forces must be balanced. So at equilibrium, F up equals to F down. So reaction of C plus reaction of D equals to 55 plus 30, 55G plus 30G. Now we can place that as we know reaction of C will substitute everything in form of reaction of C. So reaction of D will be 1/4 of reaction of C. So we'll have reaction of C plus 1/4 reaction at C equals to 85G. Now we know the expression for the reaction of C is 686 minus 245x. At first we can calculate this. So this will be 5/4 reaction of C. Now we can calculate this. So 5/4 multiplied by 686 will be 1714. So 1715, and 245 will be 1225. So minus 1225x equals to 85G. Now if we take x to the right, this expression to the right and this to the left, we'll get 1715 minus 85G equals to 1225x. Now x will be 1715 minus 85g divided by 1225. 1715 minus 85 into 9.8 divided by 1225 will get x equals to 0. Well, this is outside the range, we made a mistake. Oh, so there was a 2 over here, 4 over here. So this was basically, this was 306.25x and that was 857.5. So if we calculate it now, if we calculate this, we'll get 8. So we'll get 0.08 and this is the value of x. Now the person steps off the beam and places a package of mass M at A. The beam is now on the point of tilting about C. So if it's tilting about C, the other pivots have no reaction force, so reaction at D is 0. So if we draw this climber steps off and places a packet of mass M over here, so this is mg. Reaction of D is now 0. Reaction of C is the downward force over here. We can just consider moment about C. We'll get 0.4 mg. This is the anti-clockwise moment, and the clockwise moment is 30g times 1.1. This is 0.4. This is 1.5 minus 0.4, so 1.1. This is the 1.1 over here. We can cancel out the g's, so m will be 30 into 1.1 by 0.4. So we'll get 82.5. Now moving to question 6, we have a particle that is projected vertically upwards with speed 24 meters per second. The height of the point which is thrown from is 2.5 meters above point B, and point B lies on horizontal ground. It hits the ground at a speed of v, and we need to find this value. So if we draw a sketch of this situation, so it is at a height 2.5 meter. The height is 2.5. It's thrown up from this place and then it hits the ground. It's thrown up at a speed of 1424 meter per second. The acceleration of this motion will be minus g. The final velocity is v, and the displacement at this point, this point will be minus 2.5. We are considering upwards motion as positive for sign convention, and downward motion is negative. So at this point, the ball is 2.5 meters below where it started from. So if this was zero displacement, This is 2.5 meter below 0, so the displacement is minus 2.5. So we know the initial speed, the acceleration, the displacement, and we need the final velocity. We don't have the time, so we'll use v square equals to u square plus twice as. So v square equals to 24 square plus 2 minus g minus 2.5. So v is root over 24 square plus 5g. So v would be 25 meter per second. Now for part B, we need to find the time. So we can just simply use v equals to u plus at. V is 25, u is 4, v is minus 25. V will be minus 25. In this question, we just need the value of v, so this will be positive. We should have considered plus minus over here, but we didn't because we only needed the value. But this velocity is downward velocity, so downward velocity will be negative. This was upward initial velocity of 24 meter per second, so that's positive, but this velocity will be negative. So minus 25 equals to 24 plus minus g times t. So t will be minus 25 minus 24 divided by minus g. So this will be 5 seconds. Now we are given that point C is 10 meter above A. So somewhere over here, we need to find the time that the particle is above this line. So we need to find the time that the ball takes to cover this distance. So we know the final S will be 10, as it is 10 meter above A. This is A. We know the acceleration minus g. We know initial speed 24. We need the values of t, so we can use s equals to ut plus half at square. So for question C, s equals to ut plus half at square, we'll have 10 equals to 24t minus half gt square. So we'll have half g, or 4.9 t square minus 24 t plus 10 equals to 0. If we solve this, we'll get the values of t will be 4.44 and 0.45. I'll take one more significant figure in this one, so 4.438. So at this point the time is 4.438, and at this point the time is 0.4598. So the time in between will be, so the time in between this will be 4.438 minus 0.4598. So 3.9 98 seconds. And for part D, we have to sketch a speed time graph. You have to keep in mind that this is not a velocity time graph, this is a speed time graph. That's important over here. If this was velocity, it would be different. So this is speed. I'll also show the velocity time graph for this so you can see the difference. So this is not the answer. The VT graph. So velocity by time. We know the initial velocity is 24 and the final velocity is minus 25, because at first it's moving upwards, at the bottom it's moving downwards, and at some point in between it was stationary for a moment at the top at this point. Also is acceleration under free fall. This was a graph for acceleration under free fall, so the acceleration is constant. Acceleration is the gradient of velocity time graph, so the velocity will also be constant, meaning it will be a straight line. So something like this. So this is 25. This is the velocity time graph. However, speed cannot be negative, so this will be flipped up. So and this will have 25. So in the blue one I did right now, so this will be the speed time graph, the red one will be the velocity time graph. So this will go like this and then up. This will be 24 and this will be 25. And we have no further calculations required. They mentioned it in just in case you try to find this value of time. We don't have to do it. Now to question 7. This is a question about vectors. So at midnight, ship S is at the point minus 99 plus 20 plus 99 plus 22j, and it has a velocity of 12I minus 16j. In part A we have to find the speed, so the magnitude of the velocity, so this will simply be root over 12 square plus 16 square. So the speed is 20 meter per second. In part B, we have to express S in terms of I, J and T. So S is the position vector of the ship after T seconds or T hours from midnight. So we are given this expression also in a kilometer per hour. We know that displacement equals to the initial position plus the velocity times time. So here R naught, or the initial position vector, is the position of the ship at midnight, which is given. So S equals to R naught is 19I plus 22j, and the velocity vector is 12I minus 16j, and the time is T. So S will be 19 plus 12 T I plus 22 minus 16 TJ. kilometers. So this is the vector S. Now we are given that there is a lighthouse at position vector 26i plus 15j. So there is a lighthouse over here, and the ship travels somewhere over here, or maybe even through it, or far away. So this lighthouse is a vector of 26i plus 15j. So if we want to find the distance of the ship, so this is the ship in blue, its position vector will be S, which is 19 plus 12ti plus 22 minus 16tj. And this lighthouse has a position vector of 26i plus 15j. So this vector over here, or this vector over here, the distance of the lighthouse from the ship, I'll consider this as d. So d will be 19 plus 12t minus 26i plus 22 minus 16t minus 15j. So d will be 12t minus 7i plus 7 minus 16tj. Now we have to find in part C1 the value of t when S is closest to the lighthouse. So if we have any question like this in vector where we have to find the minimum or maximum value, we'll have to complete the squares. At first we'll have to take that the modulus of distance is root over its, if d was ai plus bj, so modulus d will be root over a square plus root over b square. So the distance squared will be a square plus b square. With that we can solve a quadratic. We can write this quadratic in completing square form, and then we can find at what value the minimum occurs and the value of the minimum. So if we do it in this case, we'll have modulus d equals to root over 12t minus 7 square plus 7 minus 16t whole square. So the distance squared will be 12 square t square, so 144t square minus 2 into 12 into 7. If we write one more line over here, it will be 12. So 12 square t square minus 2 into 12 t into 7 plus 7 square. So this is the expansion of the first bracket, and the expansion of the second bracket will be 7 square minus 2 into 7 into 16t plus 16 square t square. So d square will be 144t square minus 168t plus 49 plus 49 minus 224t plus 256t square. Modulus d square will be 400t square minus 302t plus 98. This will be 392, not 302. And now we'll have to complete the squares for this. If you won't like to complete the squares, you can differentiate this. So if we differentiate this term and then set it to be 0, so if we differentiate this, we'll get 2 into 400t minus 392, and then we have to set it to 0, so t will be 392 by 800, so 0.49. This might be more convenient to you. In this method, if we find this t, so this is the answer. So the value of t when s is closest to the lighthouse is 0.49. And now we have to comment in question 2 that if it is safe for s to continue. The condition is that if the ship is within 1.3 kilometer or closer to the lighthouse, it is not safe. We have the time at which the minimum distance occurs, so we'll find the minimum distance. So distance squared minimum would be 400 times 0.49 square minus 392 times 0.49 plus 98. So d minimum would be root over 1.96 or 49 by 25. So the minimum distance will be 7 by 5 or 1.96 kilometers, or 1.4 kilometer. This is 1.96. This is 1. So now we know that the minimum distance is 1.4 kilometer. So this is more than the safety limit of 1.3 kilometer. So it's farther away than the minimum of what is it to be safe. So we can say that as 1.4 kilometer is greater than 1.3 kilometer, it is safe for the ship S to continue. Now on to the last question of this paper. We are on a question on inclined plane and connected particles. We have the mass of P, the mass of Q. We know the angle alpha. So this is 5 and this is 12. So the hypotenuse is 5 square plus 12 squares. So this will be a 5, 12, 13 triangle. So this is 13. So we can write down the value of sine alpha and cos alpha before we move on to the questions. Sine alpha is 5 by 13 and cos alpha is 12 by 13. In question A, it's given that the system is in limiting equilibrium, the string is taut, p is on the point of slipping up the plane. So p is slipping up the plane, so there will be a maximum friction downward. So this is mu r, and we'll also have the weight, the component of weight down there, so mg sine theta, and on this side we'll have the tension. This will be the tension and this will be 0.5 mg. So if we solve equation with respect to both particles, so q, so 0.5 mg minus t equals to 0, because acceleration equals to 0. In this case, because we are said that it's in limiting equilibrium, meaning it doesn't move, so we'll get 0.5 g equals to t equals to 0.5 mg of g. And for p, the equation will be t equals to mu r plus mg sine theta. And furthermore, we can also find the r in terms of mg. So this is the weights component perpendicular to the plane, so this is mg cos theta. This will be equal to r, so r equals to mg cos theta. So if we go on here and solve this, 0.5 mg, we're replacing t with this, equals to mu into r over here is mg cos theta. So mg, we'll just have to place the value of cos theta, which is 12 by 13. Here we have found the cos alpha, and we have mg sine theta. Sine theta is 5 by 13. So we can cancel out all the mg's. We'll have 0.5 equals to 12 by 13 mu plus 5 by 13. So now we can find out mu, which would be 0.5 minus 5 by 13, and all of it will be divided by 12 by 13, and we'll get a value of 1/8, so 0.125. This is the value of mu. Now we are given that the string breaks and now P begins to move down the plane, and when it has traveled a distance of 0.8 meter down, its speed is v, and we have to find this value of v. So if we consider P after the string has broken, so after the string has broken, it has a downward force mg sine theta. It has a normal reaction force mg cos theta. Let me do the perpendicular ones in blue. So this is mg cos theta. This is mg cos theta. And the friction will be up the plane. So mu r will be 1 by 8 into r, which would be 1 by 8 mg cos theta. This is the friction. We are using this to find the acceleration at first. So the mass of P is m, so ma equals to mg sine theta minus 1 by 8 mg cos theta. We can cancel out the m, so the acceleration will be g into 5 by 13 minus 1 by 8 into g into 12 over 13. So acceleration will be 7/26 g. This is the acceleration of the particle. 7/7 g/26. Now we know the acceleration to be 7 g/26. This we are given a distance. It travels down before it. Yeah, we are given the distance, which is 0.8 meters. The final velocity is what we need to find. We also know that the initial velocity is 0 since it starts from rest. So we don't have time. So we'll use v square equals to u square plus twice as. We'll have v square equals to 0 square plus 2 into 7 g/26 into 0.8. So v will be root over 28/65g. So this will be the velocity. That's it for this paper.